Welcome to the State of Cybersecurity Industry panel series. We are proud to bring together decades of cybersecurity experience from world-class experts, executives, and strategic advisors. We will explore the present and future of cybersecurity evolution, talk about compliance and regulation, best practices, emerging threats, and the impact on the IoT and OT device market.
Good morning, good afternoon, good evening. I'm Evgeniy, and I will be your moderator today for the State of Cybersecurity Industry panel brought to you by Cybits. Today's topic, increasing certainty in automotive supply chains. Joining us today, Faye Francy, Executive Director of Automotive Information Sharing and Analysis Center at Auto-ISAC. Faye, welcome.
Thank you very much. It's a pleasure to be here today.
Ikjot Saini, co-director and co-founder of Shield Automotive Cybersecurity Center of Excellence at the University of Windsor. Ikjot, welcome here.
Thank you for having me.
Robert Kaster, Chief Technical Expert at Bosch.
Thanks, Evgeniy. Hello.
Welcome. The move to electric vehicle increases the need of supply chain security in the automotive sector. The continuing trend of energy pricing, automation, and competitive efficiency are driving the adoption of control transparency. Join our panelists as they ponder the implication of these inevitabilities. We have several topics to discuss today, and don't forget, it's a live event, so please ask your questions in a chat, and we will definitely get back to them in the end of the show. So let's begin. Let's start with something simple. Is software a bill of material? It's a business to business or business to consumer. For example, if I want to go to buy a Tesla or any other electric vehicle, should I ask for SBOM? Robert, maybe you can start the conversation.
Yeah, thanks, Evgeniy. This is something that we've been concerned with, that some of the risks of using an SBOM. An SBOM is a very powerful tool that you can use to manage the risk and your exposure for cyber threats. And I think, like Spider-Man says, that with great power comes great responsibility. So I think that we have to consider the risks of misusing SBOMs before we roll them out too broadly. And I think there's specifically risks of sharing too much information with too many people, and that needs to be considered in the concept before we start sharing it too broadly.
And I'd like to share a little bit about SBOMs as well. So, if we in the Auto-ISAC, our members are looking to build an SBOM, software bill of materials, a best practice guide, in fact, we're looking at what does that mean? What does the industry need to do for this? And basically an SBOM is a structured machine-readable inventory of software components, which are included in a particular version of supplied software, along with their hierarchical relationships. That's really important because software components, as we all know, have security flaws, and that makes the supplied software vulnerable potentially. Each component may have its own components. I know when I first arrived over here from aviation, I was stunned to learn that there's over, I think, 100 million lines of code, and it's growing in one automobile. And in a jet plane, a fighter plane even, we're talking less than 50 million lines of code. So really quite a big difference. And recently, it's been most notably a new requirement that software and technology vendors actually provide to the U.S. government's SBOMs with their products as a condition of sale. So it's really an important activity, and it will help us from a cyber perspective. But to Bob's point, it's something that does require us to really examine as an industry, and we're working through that right now. Thanks.
And I think, Faye, from the Auto-ISAC activities that we've been working on, that it's also the level of granularity that different people would need. So very deep down, very at the low level in the supply chain, you need to have a lot of detail for which software components you're using. But then as you progress up to maybe like the OEM or the end user, that they would not need that same level of detail.
Ikjot, anything to add here?
Yeah, I just want to add from a software standpoint, if we are building these products and systems, it is really important to understand when we are having this secure code development, how we can have this implemented in. And when we discuss it, when you put it in practice, how important it is to what level of transparency we need. So it's kind of really helpful to have SBOM generated and then identifying vulnerabilities simultaneously. And I was also thinking about adding customers of customers in the software supply chain. It really helps to identify with the SBOMs.
So you bring customers of customers. From my knowledge, when I'm building a car, I'm not doing everything by myself. I have third parties that are doing parts for me. So if I need to supply a car, and you mentioned the United States, it's mean the manufacturer need to go to their third parties and their third parties to collect all the SBOM information? How will this work? Would they actually ask for the information from their suppliers if you're a BMW, Audi, or Mercedes?
Yes. Yeah.
And-
Yes. I mean, in today's world, the OEMs are primarily an integrator, right? So the supply chain is very important to them, and the supply chain has many tiers in it. And so they may not know all of the different versions that perhaps a software component has that they've used. So in order to check for the vulnerability, they do need to understand that information, or certainly have their suppliers understand that and adjudicate it as necessary.
If I'm the last part of the chain, I'm a small supplier, then somebody asks for my SBOM, it's going to be used in many other locations. How can I know they will not share with my competition, for example? Or how do I know it won't be publicly exposed?
Legal agreements, of course. That's what lawyers are for, right, Bob?
Yeah, but there's also, I think, the risk of sharing too much information, because if you share it and there's a malicious external attacker that compromises the security at a company, I think there's a lot of reuse within the automotive industry. So one, like my ABS unit that I have here, that it maybe has 80% of the code that's in there is used for multiple OEMs. And if one is compromised, then you could get a detailed SBOM that maybe isn't 100% accurate, but maybe 80% accurate, that would be used for different suppliers or different customers as well. And so I think that it's sharing the information, where too much information would present a risk also for the companies that are maybe the end user of that. So I think, Evgeniy, to your question, that I think we need to be careful that we share maybe a high level with a little bit of abstraction, or maybe not in as much detail with the OEM customers. And then the tier ones have more detail about what they do, and then the tier twos have more detail about what they do. And you don't need to have the exact byte level details at the OEM for them to be able to assess the risk of, say, a Bluetooth driver. Are you using this Bluetooth driver? That would be something that you would want to know and be able to assess quickly. But the detailed version about what goes into there maybe is something that you wouldn't need to communicate throughout the entire chain.
So basically you're saying it will be quite a while before I can ask SBOM when I want to buy a new car. So we're not there yet. Great. Faye, you mentioned you're coming from aerospace, and we were very surprised the amount of code goes towards the car versus the planes. And I'm wondering, what is the difference between the aerospace and cars industry? Can you compare between them in this part of critical security?
Well, I think both industries are very focused on ensuring security, right? Let's start with that. And I would say from an aviation perspective, interestingly enough, we had something called 9/11. And that created a different environment, I would say, than what we have here in automotive yet. And that environment said that, wow, when one of us gets attacked, we all get attacked. And guess what? We now have that as our motto here in Automotive ISAC. So what that means is that we do need to work together. The bad guys certainly work together all the time. They share tactics, techniques, and procedures. They share all sorts of things very rapidly, and they don't have lawyers, right? So they get away with really sharing a lot of data and information, and we are not quite set up that way as private companies. But the difference, I would say, is that when we started the ISAC in aviation, it was a lot easier to do because of 9/11, because of the impact. It hurt everyone. I worked at the Boeing company, but and all Boeing airplanes were the 4 that went down that day. But Airbus suffered just as much. So the other big difference, there's really 2 big aerospace OEMs with 2 smaller ones. But in automotive, we have, tens and tens of OEMs. So that makes a big difference. And it's a very, very competitive business on this side, extremely so. I would say it's also competitive in aerospace, but yet the dynamics and the numbers are very different here. But having said that, I want to really applaud the efforts of the automotive industry. 14 OEMs started the ISAC, right? So they actually came together and recognized the need to do this and the desire to work together to collaborate in sharing information. So really applaud their efforts in doing so.
Thank you. Robert, Ikjot, maybe you want to add anything here?
Yeah, I think that I'm not an expert in the aerospace industry, or like Faye has spent a lot of time working in it, but I know that the challenges are probably different. That in an airplane, the cost is significantly higher and the production volumes are significantly lower. We also see that you have a explicit defined process for doing maintenance and checks on automotive, in aerospace, but in automotive you can drive down the road and see cars that have duct tape or holding them together, or spewing out smoke or something like that, and it looks like maybe people were proud of their lack of maintenance on their vehicle. So I think that's one of the challenges that we have in automotive, with being able to see what's going on in the vehicle, and that the guaranteeing that they have the required maintenance or the updates that are going to be out there. That's I think a big challenge that we have, and also the lifetime of the vehicles is something it's a bit of a challenge. That you at the beginning will have maybe 1 million or 5 million of a certain type of vehicle on the road. And then after 5 or 10 years, it's still pretty high, and then it starts to drop off. And then as you go 10, 15, 20 years, the number of vehicles will drop off dramatically. But the challenges of doing maintenance on old vehicles will increase substantially. So I think that's one area where SBOMs will also play a big role in doing maintenance of long-term maintenance of vehicles and coming up with a concept for supporting that.
So do you think we will see more over-the-air updates in case we find a software vulnerability for vehicles?
I think that yes. I think most OEMs and suppliers are actively working on solutions to support over-the-air updates. But I think the challenge that we see too is that, I know we were talking about it just beforehand, that if I found a vulnerability in my, say, braking system, in the US, we have federally mandated safety testing that we have to do before we can release the braking system out on the public roads. So like you would have to drive the car on ice and snow, and rain, on dry pavement, and make sure that it's safe to stop on those maneuvers on those surfaces. And today, there's nowhere in the world where we could do the cold weather testing. It's too warm in Canada, and it's not cold enough yet in, say, New Zealand or Argentina. So the challenge that we have too is being able to do the required testing. And as the vehicles get older and older, that trying to do validation in a 20-year-old vehicle where you take it out on the test track and drive it up on the side and it starts to roll over, that will be difficult to do safely as time goes on.
Thank you.
I'd like to add on to one of the comments that Bob made, which is really an important one, a distinction between automotive and aerospace. In aerospace, the operators are regulated, right? So the airlines are regulated, to his point regarding maintenance, and there's also someone called the FAA who actually manages the airplanes in the sky, right? So they're actually directing it. So it is a bit of a different dynamic. I will say, though, that the configuration of the network is very similar and different, but similar. And of course, the airplane's 35,000 feet up in the air when it's flying and operating. But it's an excellent point that the maintenance is very different. It's a very different dynamic in that regard. And in regard of the operator being regulated, the only one regulated in automotive is all of us who have a driver's license, and that's it. So that does make a difference.
Thank you. Robert, I want to direct a question to you about the global manufacturer changes underway in supply chain security. What do you think about this question?
Yeah, and I think that not just Bosch, but the industry as a whole is working through including security into the supply chain. I know within the Auto-ISAC, we've had several discussions on that, but we are working with some of our suppliers to put into our contract language explicitly how do we share security vulnerabilities, how do we communicate those to our other customers? When we do security pen testing, who gets access to the code? How do you communicate it if you find it, or if you find a vulnerability? Response times for if you find an issue, how long do you have until you communicate it up the supply chain? And so there are a lot of activities that we have ongoing right now with to improve the robustness of our supply chain and improve the ability to communicate. I think with what Faye, one of the challenges that we've been working on is, say, friendly findings, I think is what we found so far, where we have internal pen testing that we're doing, or friendly researchers are finding vulnerabilities in products and communicating them to the manufacturers or the suppliers. And we're trying now with the Auto-ISAC to build this trust and to get, or build our muscles, getting used to finding something and sharing it with our customers, our competitors, our suppliers, and work together as an industry to address security rather than trying to address it as a single company. And so that's, I think, one of the big changes we're working on is to have an integrated approach to security topics and findings.
Well, I'll weigh in a little bit on the global nature of the supply chain. Obviously, most of our organizations that are in the Auto-ISAC are global in nature, but we do know that in Europe and through UNICE, the UN activities on Work Program 29, there are regulations now, right? And it's looking at vulnerability management in the R155, right? So as they look at how they monitor that and how they examine what's integrated in, it's really to the OEMs to do this, that they really do need to be working very closely with the supply chain and understanding the dynamics of this and being able to document what they've done, right? And so that compliance issue will start to rear its head, if you will, in the coming months as we see the implementation of that activity.
So you brought compliance. Compliance, in my mind, is something that need to monitor changes, monitor what, how they actually operate. So we have this metrics, or like a Russian doll inside of different SBOMs. What happened when somebody changed their version? What happened when somebody changes the code? How would the end supplier will know about it? What they need to do to establish these policies, these procedures, to understand that there may be changes coming every so often?
Well, I mean, that's the OEM and the suppliers working together. They would certainly be communicating and agreeing to that in any form, fit, or fashion, right? On any changes. So I think it's a fairly robust process that they already have in place. I don't think that changes anything. I think the issue becomes in 155 how they actually ensure that the architecture of their current model of type of automobile is in fact holding up against the current threat. That's a challenge, right? So then they have to document that. That's the compliance part. How do they know, and how are they documenting that? And that's just getting underway, and I don't know much more about it than that, but I do know there's a lot of activity in that area, and a lot of our members are looking at how and what they can do to meet that.
Thank you.
Yeah, I think we have 52 days before, maybe 58 days until the R155 takes effect for all new type approvals in Europe. So I think that there's been a lot of activity within the industry preparing for it, but I think it'll take probably a few months or years before we see how that's working and how that's impacting the vehicles on the road. And
Well, maybe for somebody that's listening right now, don't know what does it mean. Can you maybe in 2-3 minutes explain about that?
yeah, so the UNECE R155 that Faye had mentioned is a regulation that in Europe, all new type approvals, vehicle type approvals starting in June, July of 2022 will have to have a cybersecurity monitoring system in place. That the ISO SAE 21434 is a norm that was just finished last year, talking about how to do security in automotive environments. And they're saying basically you have to follow that norm starting this next month, and for all new vehicles that are released. And I think that that's a good step, that we had a very strong agreement between the U.S. And Europe. I know Japan was also active in doing that. In India, there were several. We tried to make it truly a global approach to cybersecurity, not so much what to do, but how to do it and how to do the evaluation. And then the R155 is basically saying when that you have to start doing it in this year in Europe, and then in 2 years for all new vehicles that are sold in Europe. And Japan is following very soon after that. I think for the U.S., Canada, that we have a different strategy for how we do the approvals. We do self-certification rather than type approvals, so that doesn't apply directly to the vehicles that we would have here in North America. But I think you'll see a lot of the strategy and the policies for doing it will be adopted here. And if someone wants to sell a global vehicle, they would have to follow that policy for doing the type approval globally too.
So basically, you say there is a good material to read before you bed. Okay, now I know what I'm going to be reading.
Yeah, it'll.
Let's switch from regular cars to a bit of the cars that self-driving cars. There was an interesting article, I believe 2 days ago, when a police person stopped a car without lights in San Francisco and then realized there was nobody in the car. Because it was
And the car tried to get away.
No, not there, yes. But I'm wondering, Ikjot, can you maybe tell us about what are you seeing, how it will change the supply chain security impacting in an autonomous vehicle, because they all software pretty much.
So there is actually one, we need to make this distinction, and this is not just covered here with autonomous vehicles. Let's throw one other component, which is connectivity, and having more connectivity and more localization along with this autonomous, because when we talk autonomous vehicles, it's more about decision making and intelligence. But when you throw in the mix the connectivity, now you are completely into this, because the awareness based on for the autonomous vehicles to be fully autonomous, they need to have this situation awareness. So we'll have connectivity. And why I'm bringing this in here, because we have been dealing with the supply chain issues, and so far what we have discussed are based on what is happening might be in a one vehicle, but when you have this possibly coordinated on one particular vehicle in a local network based on direct communication has been impacted, how would you first of all identify that and then acknowledge it in the supply chain, and then work on the OT updates and all that? So that brings a new kind of a challenge. I think it would be worked upon once we have a completely clear defined way. And within the release management, I think we need to make some changes with respect to autonomous vehicles, because what we are dealing with the SBOMs in this case, we are having the dependencies And I work with by the way, software developers. And when we talk about secure software development for automotive industry, which I'm doing right now, actually teaching this, what we realize that there is a security overhead which comes with a lot of connectivity and autonomous vehicles, and this also implies to our previous question on aerospace. If you compare the stats with that, there's a very high, almost 10 times more security overhead in automotive, because we need to have these testing scripts to not only identify known vulnerabilities but also unknown vulnerabilities. And when you put that into the supply chain, these security software developers, they need to know it early on in the phases. So as soon as you identify it, the timely manner in which it needs to be identified within autonomous vehicles has to be much more quick as we see it today. So that's something we have not discussed so far, and I wanted to bring that to attention, that it is going to be much more complex because we're dealing with the intelligent machines in this case, making decisions based on what they are seeing rather than the human beings.
So basically, you're saying if we discover a vulnerability or a problem right now, can we even do an update over the air because maybe the car is driving right now and how it's going to affect the car? Or we need to make sure the car is parked, if I understand correctly.
Yeah. So it needs to make that decision appropriately first. So there goes the integrity, not with respect to the security update, but as well as with the mechanism which is built in the autonomous vehicle to actually apply that and not fool you. So I'm trying to say there can be adversarial or malicious intent there or code built in the algorithm itself. So that's something to be worked upon as well.
Interesting, thank you.
Yeah, and I think building on what Ikjot had mentioned there, that we see two big factors that are driving the need for security. For one is the connectivity, where you have the increased exposure and the ability for someone remotely to influence the vehicle. And then the second one would be the authority of the sensors or the actuators inside the vehicle. So if you had a system that was only doing the ability to say roll up and down your window, that wouldn't be something that has as much of a safety impact as something where you could steer the car. Or if you don't have a steering wheel in the vehicle anymore, then the steering has much more authority over the system. And so as that authority increases, you have to have appropriate levels of security to protect it.
Thank you. If we're going to stay in the academia part, what we need to teach people, how the academia needs to respond to make sure we're ready for all these changes. Anyone wants to take this question?
I can start that. I was hoping Faye might start that. So I am in academia, so I can start that question. I've been actually in Shield. I'm also in charge of working on the education and training for automotive security. For future, we're trying to figure this out on our own, which is quite difficult and challenging. When you put these skills together and competency and develop a competency matrix, you realize that it's a complete mix of 4 different corners, which is computer science, engineering. Within engineering, you have electrical engineering, mechanical engineering, and these people need to understand technology in the similar terms and context. So what we are struggling right now, and also forget the core component is security, which is apart from part of computer science. So when we are developing these programs, our focus is to bring the best or the low-hanging fruits. What we can see is embedded security. Some parts of the engineering which we need at least to really understand, okay, what is this system that we are working with? And this is a system of the systems. So you may not know everything, but you need to know how the threats can be passed and can found its way to the vehicle or particular ECU or particular component. So to have that overarching idea of cybersecurity within automotive, if we just limit ourselves to vehicle today, I think that would be sufficient. In future, we need to go for the network of vehicles and the fleets completely. But for the workforce, what we are right now what we need right now is some sort of certification, a template that can define, okay, these are some of the core skills required for a professional to be automotive cybersecurity. I don't want to label it like engineer or all those roles that we have, but we need to have that as soon as possible so that we are not hiring people and making them understand it. Rather, they would have these skills with them. So maybe some sort of certification we have in cybersecurity SCISSP as a very major one and well, core required, but how we can translate that and classify these domains within automotive industry. So I think that's what is required right now. That's how we will see some sort of shift. I know Faye would be able to add more to that.
Thank you. I can. So we are embarking on developing a program right now. In fact, it's actually running right now in Ypsilanti, our advanced courses. So we have been very fortunate to be granted a cooperative agreement by NHTSA in order to develop a training program for automotive cybersecurity. So we call that our ACT program, ACT, Automotive Cybersecurity Training Program. And that program consists of fundamentals in cybersecurity all the way up through advanced training, which includes hands-on pen testing and so forth. And we are looking at what does this mean from a certification perspective, and what does this mean for the universities that are maybe getting some of these students? How can we support this in the broadest sense of the word? So we will be working on that all this year and hopefully coming out with some ideas and some concepts of how we can continue to help support training the industry, specifically the automotive industry, of course, and then what else we might do in partnership with some of the universities to ensure some of the needed skills are embedded in what they do. We are using our members to help develop this course and partners, right? And so our members are reviewing all the material. They're suggesting where we need to focus, other different areas of concern and so forth. And so it's really quite a robust activity, and we're really looking forward to the culmination of what we will produce from there.
And I think, Evgeniy, my twins are out of the house studying, and my wife said I should go back and get my PhD with all my free time to get out of the house a bit. And I've been taking some classes at a University of Michigan Dearborn, where they have a program that's targeted towards people that work full time and then can take classes in the evening. And I found that to be very beneficial for me, for having someone who has experience with and within the automotive industry and with engineering, to be able to have some formal education and that perspective for what it takes for cybersecurity. And I think that's a big challenge that we have, that trying to take the concepts, understand how it works, and then also be able to communicate the needs to our leadership. That if a lot of the questions that would come up are that say, well, when we work with in terms of quality, we have measures and say that this many parts have failed, this many are likely to fail, this is the expected cost impact for that. And if you look at cybersecurity, that a lot of it is we find a risk from an internal pen test, and they say, well, how many parts have failed? And you say 0. And how many are likely to fail? And we're like, well, someone somewhere theoretically in 5 years maybe be able to do this. And so how do you communicate that risk to someone who's approaching it from a quality or safety impact? And I think that's one of the big challenges that we also need within the industry, for support from academia for how to manage and understand and communicate cyber risk to people that are very good at their job but don't have cybersecurity background.
Robert, what you just mentioned is exactly what I mentioned as translation. We have maybe same technology, and then we're working with it. But when I just got to know when even electrical engineers talk to automotive engineers, when they talk about technology, they are talking in different terms. For them, it means something else. And when, as computer science, I will talk about technology, it would not be the same thing that I'm trying to communicate. So I think there's a lot that goes into the translation of the technology. And when we talk about risk management and what you mentioned about quality assurance and safety, I think when I started learning about Misra and AutoSAR, I realized how important it is. Actually, I was teaching my students, and this is important for them to know. When you write code, there are safety critical systems versus security related impacts that you would see, and how would you need to have that distinction in your mind, and you need to set priorities to risk to manage and address these within when you're fixing this in the code. So that goes to that down level that these software developers now need to understand, okay, what is that they're working on? And I think that's not really communicated.
Do you think software developers understand the security aspect?
I tried 4 months.
Do they care about the security aspect?
No. I'm sorry being honest, but that's the truth, because the most of the software if you see in the production, it's always about the two things. What are the requirements of the customer or client? So that's equals to the functionality of what we're developing. And the third thing is the deadline. So you want to make sure it's put in the deadline, and you're just having a checklist which is supposed to tell you about the functionality, rather than if it's not enforced security, then you would not be doing it.
So I'm going to jump a question and we'll come back. Sorry, Robert, you want to add something? Yeah.
I would just say that I would say that from the people that I've worked with, the software engineers, that they do want to do the right thing for security. And I think that the challenge is making processes that make it easy for them to correctly implement security measures, rather than having no processes or processes where it's difficult to implement it. And I think what Ikjot had mentioned is that if you have a process where it's very difficult to implement security, then it makes it more difficult for the developers to successfully implement it. And I think as security leaders, that it's our job to try to push and make it easy for people to correctly implement robust security.
I just want to add last one thing. One of the students actually come up with an idea. It would be easier for them as software developers if they would have a virtual security assistant who would be able to tell them, okay, this is the problem here and you need to fix it for this reason. So it's like an automated process for them in their framework where they're developing, so that they don't have to go and find all the information, and have their process already doing it for them. So that will be a feasible and tangible solution.
Very creative. If the cars are made out of software mainly right now, so how fundamental is this, especially if the programmers don't really want to touch base on security? Like, what do we do here? We say it's important, but then people that create the software are not really focusing on it.
Yeah, I would challenge your characterization, Evgeniy. I think that people do want it, and they do feel that it's important. I personally, I've spoken with a lot of people, and we have a product cybersecurity awareness training that we do, and we've had I think about 1,000 people that we've worked with, and just within our company, and I haven't met anyone who thought that security wasn't important, or that it didn't affect their job. Even like the sales guys and the marketing guys, the quality guys in the plant, that they all see that cybersecurity is important for them to do it. So I think for this one, how fundamental is it for the automotive sector? I think that it's absolutely essential that we have robust security in place. And we also have to have the protection or our systems built up so that when we do find security issues or gaps, or that we are able to respond to it quickly, and also on a high level, and not just, or say for some fixes, it may be that we can't just fix it in the specific module or the software module that had a bug, but we would have to approach it on a high level and maybe shut off functionality, or have an interim solution, or maybe we have multiple layers of security so that if we find a single vulnerability, that there are other layers of security protecting it, so that it doesn't require immediate action for that issue.
So I send you a curveball, and you Dutch is really well. So thank you, very, very, very good answer.
No, but I think that it is. I know Faye, you would say too that it's within the Auto-ISAC there is a very strong community with a lot of discussion where we're trying to improve security for the industry as a whole, and we're explaining how we do it within our company. Other companies are explaining how they do it within their company, and learning lessons from each other. And I think there is a significant commitment towards making this a fundamental factor as we move ahead.
Yeah, I'd like to talk a little bit about that. So it really is important, right? Cybersecurity is everyone's responsibility. And that's really not a cliche. We all recognize it in our daily lives, how important cybersecurity is. But I think to the point where, have we been practicing building in security in the far past? We weren't concerned about it. Now we are. And it's a journey. And I have to say that every day I learn something new, as we all are. And so as we go through this journey and as we are educating ourselves, we're recognizing the need for more of these basic and fundamental understanding of building in security from the design, from the get-go, from the software, developer. Historically, we didn't worry about it. And that's the shift that's happening. And I think that's an important shift. What we do in the Auto-ISAC is to really support that concept and that idea. And we not only do threat and information sharing, we also do education and awareness. Training, we have a group that meets regularly where we do members teaching members. So we'll have members come in and do a 90-minute webinar where they'll talk about what they've discovered or experience they've had or how they are approaching cybersecurity in their environment. And that has been so helpful. We have hundreds of people that attend those because they're so powerful to hear from other automotive experts that are, struggling to find their way and what they've done to be successful. So it is a journey. It is constant vigilance. I mean, the more we learn, we have to learn, right? And the smarter we become, the faster and smarter those threat adversaries are. And so we have to be constantly vigilant, and we do have to embed security into everything we do. Historically, even in aviation, we didn't have a security regulation, right? And really, theoretically, right now, we have no official one here in the US. We have best practice guides from NHTSA, and we have that wonderful standard that Bob mentioned, ISO SAE 21434. So the industry is learning, they're doing, and they are very focused on ensuring that everything that they do is cyber secure.
Thank you.
And maybe just a quick plug for the formal education that I wanted to mention that my professor, our advisor, Professor Ma, that we sit and talk over the course of a couple of years about this is what I'd like to do, and she'll go through and say, no, you have to do this. And I think that that's one advantage of having a formal education that I know, Ikjot, you can, you've dedicated your life to doing that, but it's something within the industry that it is very good to have the external perspective, and in a formal environment, I think that that's something that's been very beneficial to me. So.
And I just want to say one thing. Robert, you mentioned that none of you have met thousands of people and they care about security. That means I can say that there are these industries where I just want to say, like, when people are learning, so we want to tell these to write the code securely, but there is no incentive there. Until and unless the industry is telling them, or the company or organization where they're working, if there are processes that enable them to learn and then implement, I think that's what's required.
Yeah.
And we need just organizational processes. And when I talk to students about these organizational processes, it doesn't make sense to them until we really get into these software engineering aspects, and then they will understand, okay, that's why it's important. And now I know the why, rather than just knowing, okay, I have to do it and it's difficult for me.
Mm-hmm.
Now they know the why, so that they can see this is safety critical. So it makes sense to them. Okay, I need to be careful and I need to put this on priority.
Yeah. To build cybersecurity is part of our culture. So
Yeah.
As all of you mentioned, that we have more awareness right now, we're learning more about it.
Mm-hmm.
And certain hacks, unfortunately for the hack, but good for the education, like Log4j was an eye-opening about application security. So all this bad thing that happened, but on the other side, they teach people what and how they can do better. So I would like to thank all of you for joining me today for the State of Cybersecurity Industry panel brought to you by Cybits. You guys did an amazing job. I've really learned a lot today. And I know, Robert, what I'm going to read before I go to bed right now. Thank you very much. I will learn about cars and cybersecurity in Europe. And of course, for people that listen to us right now, I'm going to listen to us in the future as well. So thank you, everyone, for joining us today.
Thank you.
Okay.
Thank you.